Hey everyone, we're going to solve example 2 using row reduction and the 3 elementary row operations we discussed. Now remember, this is an augmented matrix, so I'm going to draw this line just to remind you that 5, -3, and 7 are on the right hand side of the equation. Let's row reduce. So we'll start off with the matrix. Now just note that it seems to be that we have 3 equations and 4 unknowns. So that's a little bit different from the previous one that we did in class that had 3 equations and 3 unknowns. So let's see what we can do. Well, I noticed that this is 1, that's kind of nice. This is 0, that's also kind of nice. And this is -1. I'd really like that -1 to be a 0. So why don't I add row 1 to row 3? And then this will be a 0. Oh, look, -7 plus 7 is also 0. 0 plus -4, well, that's still -4. And then 6 plus 2 is 8. Now remember, be careful, add 5 to 7 as well. Don't forget about that right-hand side. All right, now I'm liking this column right here that I'll highlight where it's just sort of it's all zeros below the first row. Now, I just want to note that actually the second column, we kind of get that for free, too. So maybe going forward, we'll take a look at this pivot. So maybe you could see, next step, I think anyway, should be 4R2 plus R3. Right, and then these zeros, of course, will stay the same, but then we're going to have zeros here, too. Now, note what happens here, right? -3 times 4 is also 0. So let's pause for a second and see what we've got. We have a 1 right here and a 1 right there. Can we really get this any further, right? The bottom equation, if we were to write it out, would just be not an equation. So effectively, we had 2 equations. So let's write this out in equation form and see what this looks like. Right, so we have x1 minus 7x2, skip a space here, plus 6x4 equals 5, and x3 minus 2x4 equals -3. Okay? Let's see, we've got a bit of space here. Okay? So in this situation, we can solve for x1 and x3 in terms of x2, x4, x2 and x4, right? So what we do in this situation is we say x2 and x4 in this situation can be any value that we want. They're the so-called independent variables if you want. So we can say let x2 equal, call it s, and x4 equal t. So when we do that, we can now solve for x1 in terms of x2 and x4, but really in terms of these constants, s and t. Let me just say for any s and t in the real numbers. So now I'm going to say x1 equals 7x2 plus 6x4 plus 5, and x3 equals 2x4 minus 3. Or another way to put that is x1 equals 7s plus 6t plus 5. And x3 equals 2t minus 3. Okay? So this right here is our solution. Now that's a little bit different from what we had before, and the reason is we effectively had 2 equations and 4 unknowns. So maybe you could see here that we have infinitely many solutions, right? Because s and t can be any real numbers. So what you do to find a solution is you just choose a value for s, choose a value for t, plug it in, right? Plug them both in. They give you values for x2 and x4, and then they in turn give you values for x1 and x3. Okay? So I just want to compare and contrast this to the matrix that we had in class today, right? Because in class, we had a matrix where it was nothing but 1s and 0s in the coefficient part. Here, we weren't quite so lucky, but we were still able to solve for the values that were labeled as 1s. In particular, note that they were the first values in their rows. So we're going to see what exactly that means and how that relates to something called reduced row echelon form. That's all for this video. Thanks.